In this episode I want to show you how we can take advantage of the super whites or the super bright values in an HDRI for our work. And I start here just with creating a material, and again I place in the luminance channel my HDRI. And I take here my OpenEXR file, and that's pretty much it. And the next part is, of course, then to just control click here and use exactly the same file, but this time the low dynamic range. So we have a comparison inside, and I can show you then the differences in it. First of all, I want to have here, of course, a plane in the scene where I can attach this material to, and I set here the height to 200. As usual, when we have a 360 by 180 degree panorama, that means normally the standard that goes one time around a sphere, then it's normally the standard, but not the rule of course, to have a 2:1 ratio in the picture. So 400 by 200 fits then exactly this. I duplicate this here of course as well, just by command drag this down. Click here in an empty space to deselect everything and drag here on the second plane then the material number 1, the low dynamic range, and this is the high dynamic. So high dynamic, we put high to make that easy to memorize. And when I go now here ahead and render it, we won't see any differences. Maybe this is a little bit brighter, so it's sometimes not that simple to get exactly an LDR from an HDR. So there might be a slight little difference, of course, but it will go even heavier when we go then to work with it. And with that, I have in mind that we take here just a camera. And I drag here this frame very close to it, move it here inside, check it. And then we have here in the camera view now these two pictures. You can see here the highlighting in release 14 works very nicely. And the next step is I want to have motion blur the first. So I go with the camera active and check here and keyframe to this position. Then I go one frame to the side, and I move this here completely to the left. So I have a lot of space to move. So when I go then here, I come to this place, and then I go to the right side here and click again in a keyframe. So we have now here exactly a movement. I could even take this keyframe here away, but you see it jumps a little bit. I leave it now here, and then I go to my render settings and I choose render physical, and then I get here a new point in my options, and I go here with the motion blur into my game. And let's take here just from the start a higher sampling quality to get nicer results, because I don't want to make you wait all the time. So I click here now on the picture viewer, and I come back when it's rendered. So it's done, it's rendered, and we can see here clearly that the HDRI produces a complete different result than the low dynamic range image. So for me this is a clear winner, and I think I have not to tell you more, because in the moment you want to combine, for example, practical footage with 3D footage, then we need this quality in our pictures for sure. There's no way around, and tricks are not really stable in that way, because this is something that we have achieved during render time, and this is a quality on its own. When we don't have this quality, when the sun is clipped at 100% or at 1.0, then we get here this faded low light area. And combined with practical footage, this looks like fake, and everyone will say, yeah, I see, it's CG, it doesn't make any sense. And so it renders literally your work worthless. So my suggestion is, in the moment you have access to better quality, to HDRI, use it, because the rendering time is not longer based on that. It's just a mathematical expression here. Because if the value is 20 or 0.2, doesn't matter to cinema at all. It calculates these pictures anyway. Okay, so that was the first one with motion blur, and let's do another one. And the next test should be then refraction, and I want to have a cylinder here in front of the two images to show you how much light finally is refracted and how it works out. So let's put this cylinder here just in the middle of the two images, expand this just a little bit. I don't want to have any intersections here, and I need of course a new material, so I drag this on the cylinder, and we need this here of course not in luminance, in a transparency, and when I check this on I need only to set up maybe 1.5 here in the refraction, and I leave everything in standard. So I have set here up the size already, and you see here in the physical render I have checked off everything else. Then we want to see what happens, and I come back when it's rendered. So, and I hope it's visible what we have here. First of all, the little highlight from the pole, we see that here, it's just grayed out. And I hope the compression of the tutorial doesn't eat it away, but the sun here has a very clear definition. It's white, it's clear, and here it's more grayish, not what we expect from a sun behind just a bottle or something like that. And to be honest, this one here looks not bad, and I think with a little adjustment in post it would look as good as this one. But keep in mind, when you start out with a better result, you can tweak it even further to something spectacular. But if you start out with something like that, the limits are maybe already there. Also here, the tiny little highlights, and I go here just for a moment to 200% to make that more clear. These highlights here come through. Very nice. Not so much here. So that's maybe a little bit tiny here, but it's the difference. And exactly there comes finally the quality into the whole picture, because this is only the refraction part of it. Keep in mind, we have motion blur, we have depth of field, and we have reflection. And all of that in a scene makes finally a lot of more sense. Okay, so next one, depth of field. For the next part, we don't need the cylinder anymore. What we need to do here is to have a look to the camera. And we have an eye on the physical camera in this part of the tutorial. What we don't need to set up at all for the physical camera is here in the attributes manager and details the depth of field map, front blur, map, rear blur, and as the name said, map. This produces a map for example this standard rendering engine inside of Cinema 4D, which finally affects then, if the standard rendering engine is used, the multipath rendering. It has no effect to the physical camera, so just ignore it. Next point. When we have here in the Attributes Manager and the Physical tab the f-stop, then I want to give you in a nutshell just some simple truths. The f-stop, the maximum opening of the aperture, let's say from a very good lens 1.2. And exactly here I made the first mistake. There's no very good lens just based on 1.2. That's the biggest myth I always hear when people brag about lenses. Of course I want to have these lenses, but this number here says nothing about the quality of the class. And as we have no class in Cinema 4D, f-stop is here a perfect use, because it is a mathematical description and we calculate stuff here. So f-stop is perfect here. F-stop and the maximum aperture says something about the construction, how it is done, the ratio between the diameter of the aperture and the length of the lens. Let's make it simple. I put here 1 into the f-stop. That means 1 divided by 1. That's the slash here. It's always easily forgotten. If a lens has a length of 50 millimeters and the maximum aperture when it's wide open is 1, then the aperture diameter is 50 millimeter. So when I have a lens, for example, of 2 and a lens of 50, then the aperture has a diameter of 25 millimeter. That's the whole truth. You could have really Coke bottle buttons inside of your lens. As long as the aperture works, these values would stay the same. Different to that would be a T-stop, which you use normally on feature film cameras. These are more expensive because the glass is measured by itself. More expensive when they have the same values, of course. So it has nothing to do with the quality or whatever, it's just a mathematical description of a ratio inside of the lens construction. This makes it possible that you have maybe custom values like 0.7. Some directors in the history of movie making have used them, which results in a super shallow depth of field. More commonly used are 2.8, 2 or whatever, but you will find in many lens lineups also values of 1.2. So I stick with this value here for a moment. The aperture has nothing to do, finally, to deal alone with the depth of field or the shallow depth of field. For that, we have to have some measurements. And then I go here to the object area. The most important part is, of course, the focal length, but if it is longer, we go further away and we get a similar result, because the perspective doesn't change and the physics of optics will not change either. So that's not really the measurement how to get a shallow depth of field if we have the same framing of the actor. What really matters is the sensor size, 70 millimeter like for IMAX, or for the highest quality in filmmaking these days, when we talk about celluloid, 70 millimeter is huge, it's expensive and not so often used. But for the sake of demonstration here, 70 millimeter gives me the best, of course, a very shallow depth of field. The next parameter in the whole game to get depth of field, and I have to explain that so you can reproduce this, and I switch this here on for a moment just to see where I am. Here is my object and here's the camera. This reference point is important in terms of distance to the camera, because the more distance I have, if I use here maybe 1 kilometer and scale all up, I will go over the hyperfocal point. That means the point after that point everything is sharp and I don't have any shallow depths of field. So I can move here the camera very close to itself to get here a huge distance between object and camera reference point. This should enable normally a nice depth of field. But again, it's always the real world measurements, because with the film gate we have set some reality to the real world. If we scale the film sensor size and the distance here, we have a different ratio. So okay, that's the long story short, or the short story long. I don't want to go too much into depths, but if you like to reproduce this, you should know this. Okay, I switch this one off again, and then I render this. Maybe I have to adjust some values, and I tell you that after the rendering. So rendering is done, and as you can see, you see nothing because I have forgotten to switch on depth of field in the physical rendering, and I have done it right here, right now. And now you can see the difference. Here we can see the blooming of the sun and some differences here. There's more game in the whole picture, more contrast, you can play more. And of course it will look more natural compared to practical footage than the lower area here. Very nice example, and I will render one more out when I go here just with my reference point closer to the whole thing. Maybe that's already too much. This is the one I want, and so I'm back with results after I have rendered this. And here we can see, even with a lower amount of depth of field, we have these nice bloomings here, just grayed out and not really nice. The sun itself is just a cloud, it's not really light. And of course all these other little parts here in the scene, this pole has not so much light, but you see in this area here in the facade, that is really glowing compared to this area here. I think it speaks for itself. It doesn't need so much explanation. And the overall quality of the picture, we see it's pretty similar, except for these effects. And people who know cameras will see that, and they will miss it if you don't have it. Okay, off to the next one. The next one should be pretty simple, but for that we don't need depths of field here. We could have this, but it would just double the amount of work. And I need here only a plane. And I need to move this down. And maybe I take a different camera here for the time being, to not destroy the camera position before. What I'm doing here, I prepare something that is called reflection. And the reflection itself works, of course, since the physical camera or physical renderer in the same way, and it's fantastic. And I do this here like I have shown you that in part 1 already. The reflection a little bit down, and I hope that will work to our advantage here. And maybe we can see already in a result. You can see here the sun. We don't see this one in this picture here. And all these little highlights. That's very important, especially when we take a look back to refraction, to motion blur, and to depth of field. And of course, we could go into global illumination as well, but I wanted to give you, first of all, something that should be considered in every rendering. Global illumination is a specific case or image-based lighting, but these 4 areas need certainly the advantages of HDRI and the brighter highlights, because then things look a little bit more natural. There will be much more to discuss, and please continue with the series, because I think it's one of the more important series to know. Thanks for listening so far. See you in the next one.